So basically now the rest of the notes are just a bunch of examples of more of the U substitution process. If I were actually in class teaching this to you today, I would definitely be pausing and letting you work, and then we would like kind of make it a conversation of what you would suggest the U to be and that sort of thing. But since this is just a video and we're just kind of working a little differently, I'm just going to go through and do the examples, and I would suggest pausing the video and giving yourself a chance to try something out and that sort of thing as you go. Okay, so moving on to our next example, I have the integral of the sine of x plus 9. Very often, guys, the argument is the best choice for your U substitution. It doesn't always work, but it does happen a lot. So, like I said, you'll start to get better and better at your choices. So I'm going to pick my U sub to be x plus 9. I'm now going to take the derivative, du dx, which would end up being 1. Then when I go to solve for dx, I would multiply both sides by dx, allowing me to see that du is equal to dx. At that point, I'll come back to my integral. I'll rewrite this as the integral of the sine of u, okay? And dx is really du. So I can make that switch too. So this is, again, you always want to stop before you integrate. Check to make sure that the letter and the du or dx, whatever it is, matches up, okay? So what is the integral of sine? Well, the integral of sine is going to be what? Hopefully you're saying negative cosine. So I have the negative cosine of u, but u would then be replaced as x plus 9. So I'm going to do that now, and then put my plus c for my final answer. Okay? Next problem. Okay, cosine of 5x. So once again, we have to think about what should we make our u. Our u in this case, we're going to go with the argument once again. Make it a 5x. Now take the derivative, du dx is equal to 5. Solve for dx. du equals 5 dx. Divide by 5. And we're looking at du over 5 is equal to dx. Coming over here, integrate the cosine of u. dx is really du over 5. So looking at this, you see that I have a u and a du. Now this is over a 5, so it would make sense to me to pull that 1/5 through the integration symbol so that it looks like this. Okay, and that's definitely a worthwhile step to take because I think that's a little bit more clear to see. And then we have to take our derivative of cosine, and the derivative of cosine is sine. So, integral, sorry guys. So I have 1/5. I have the integral of cosine, which is the sine of u, and again, u is really 5x. And then I have my plus c. Okay, next example. We have our sine squared x cosine x. Okay, so this one I would say is a little bit trickier. Options, u could be the sine squared. U could just be one of the sines. U could be the cosine. So when you're new at it, honestly, just pick something and see what happens. What I like to think about when I make my choice is whatever I choose u to be, the derivative is where it will go next. And I like to think about how when I take the derivative, what will that do in affecting my problem? So my choice is actually going to be to choose just the sine of x. Okay? And let's go through my logic. Du dx, the derivative of sine, is cosine. When I solve for dx, every time you solve for dx, whatever is next to that dx, right, whatever you just took the derivative of, doesn't that end up being in the denominator? Don't I have to divide by that? So du over the cosine of x is equal to dx. Okay, doesn't that happen all the time? Look over here, right? We had the 5, and look, the 5 ends up in the denominator. So the reason why I chose one sine is because I realized that sine would turn to cosine, and cosine would end up in the bottom. Do you see what's going to happen for me over here? Okay, so check this out. This is now, the sign is u, right, squared, because I have two of them. I still have this cosine of x, but dx is du over the cosine of x. And that's what I was anticipating to happen. I knew that would end up in the denominator, which is what would work out nicely for me here. So what am I dealing with? The integral of u squared du. Piece of cake, right? So we go through, we get u to the third over 3 plus c. U is really the sine of x, so I'm going to write the sine cubed of x over 3 plus c for my final answer. Okay? Next. Okay, so another trick with our u subs. Okay, so that one, helpful to think about what would end up in the denominator. Anytime I see something that repeats, I try that as my u sub. Okay, so I have u equals the square root of x, which is actually, let me write that as u equals x to the 1/2, right? They're the same thing. So when I go to take my derivative, du dx is equal to what? 1/2 x to the negative 1/2, right? Okay, so then let's see, let's rewrite that. Du over dx equals 1 over 2, and we'll put the square root of x in the denominator, right? Because we know that x to the 1/2 is the square root, and that makes it go to the bottom. Okay, I have to solve for dx, so that gets me 2 root x du equals dx. Okay, how did I get that last step? Well, I just noticed I had a ratio, so I multiplied the diagonals, right? So I got the left side and the right side to get my answer there. Coming over here, I have e to the u over u, and then dx is really 2 root x du. Okay, so now let's take a moment and look at this because we have an issue here. Maybe you're thinking this didn't work. Do you see that this is a du? That's good, that's good. That's not okay. I have the square root of x in my problem, and I have a du. X and u cannot both be here, okay? So we have to think, do I pick a different u sub, or is there something I can do to make this a u? And I look at it carefully and I say, hey, look, u really is the square root of x. So this is a u. So let's rewrite that. We really have the integral of e to the u over u. See that too? I'm going to pull that through my function. The square root of x is really a u, so I'm going to put u over 1 du. And you can see how nicely this will work out for us because I can reduce. So I have 2, I have my integral of e to the u du. The integral of e to the x or e to the u is e to the x, so I have e to the u plus c, and then I have to replace my u, so 2e to the square root of x plus c. And there's your final answer. Okay, so definitely a good thing to look at right here. Okay. Next example. Okay, looking at what we have in this example, what do you think your u sub should be? Okay, hopefully you're looking at this. I picked 1/3 x minus 8. And by the way, oftentimes there's more than one way to do a problem, so you may pick a different u and you'll still get the same answer as me in the end. Okay, so here we go. Derivative du dx equals 1/3. Solve for dx. Again, I'm going to just multiply those cross products. So 3 du is equal to dx. Okay, come over here. I really have the integral of 1 over u to the 5th power, right? Because this is just like a 1 here. That was my u to the 5th. And then my dx is going to be 3 du. So like I just did before, I'm going to pull the 3 through and put my du here. Instead of writing 3 du here, pull the constant through the integration symbol. Okay? I'm going to rewrite this actually as u to the negative 5th power. Okay, check to see that the u's are matching, so we're good to go. Now we can integrate. So I have 3 u. If I add 1, I get negative 4. Divide by negative 4, add my plus c. So we're looking at what here? We have a negative 3 over 4 u to the 4th plus c, and our u is really 1/3 x minus 8 to the 4th plus c. Okay, final answer. Next. Okay, pick your u. I'm going to pick 3 minus 5t to the 5th. Does that make sense? Hopefully you're starting to get better at your choices here. Take the derivative, du dt. Okay, so let's check that one out. Since they picked a new letter for me, I'm taking the derivative of u with respect to t. That's where that notation comes from. Okay, the derivative is going to be negative 25t to the 4th, right? And then I'm going to solve for dt this time. So du equals negative 25t to the 4th dt, and then divide, so I get du over negative 25t to the 4th equals dt. Come over here, t to the 4th is here. This is going to end up being the square root of u, or u to the 1/2 power. dt is really du over negative 25t to the 4th. Okay, it would have been an issue that I have a t to the 4th with a du at this point, but you can see that they're going to reduce nicely. This negative 25 on the bottom is going to pull through as a negative 1/25th constant pulled through. We have our u to the 1/2 du. Okay, so this is so repetitive once you start to get the hang of this, the whole u sub, the derivative, and the integration process. So let's just finish this problem out. We're going to bring our constant down. We're going to integrate. So I have my u. I have to add 1, which gets me 3 over 2. Dividing by 3 over 2, I get 2/3. I add a c. Go through, I get negative 2 over 75 u to the 3 over 2 plus c. U has to be replaced. Go back to your problem and sub that in. Okay. U substitution over here. Okay. This one, I started my first time with x minus 1. Then I talked myself out of it, and then I went back to it. So let's see. That means this one's a tricky one, guys. Here we go. Okay, so the derivative of u is du dx equals 1. Therefore, du is equal to dx. Okay, so that's simple enough. And then we're going to come over here, and we're going to write x squared. And then we'll have u to the 1/2 power d. I guess I'll put dx for now. Okay, so let's see if I like that. So I have my x squared. I have my u. Now, du and dx are the same, so actually, if you want, let's go to du right away. Okay, so we made our u sub, so I'll make this substitution just to kind of continue the way I've been doing all my problems. But this is why I decided I thought it was wrong at first, and then I went back and forth. This guy right here. I'm not allowed to have an x when I'm in terms of du. Okay, so I'm not allowed to have an x. Is there any way I can get rid of that x squared? And in the end, after playing with different u subs and still falling into the predicament of not having the letters match up, I went back to this and I said, well, if u is x plus or x minus 1, if I add 1 to both sides, u plus 1 is equal to x. True? Right, I just add 1 to both sides. And then if I want x squared, can't I square both sides and get u squared plus 2u plus 1 equals x squared. Right, basically I foiled the left-hand side to get this. And then I rewrote it like this. U squared plus 2u plus 1, because that's really x squared, times u to the 1/2 du. Now everything's in terms of u. I can distribute this. So I'm looking at u. When you multiply like bases, you add their powers. So 2 plus 1/2 is going to be 5/2. And then distribute again. So I have 2. Adding this, I'm going to get 3/2. I need my u. So u to the 3/2. And then plus u to the 1/2 du. Okay? Once I've distributed, now I can just integrate. So adding 1, and this is where, go slowly with this, pause the video if you have to. They're just fractions, but we mess these up a lot, guys, so be careful. When we're adding 1 to this, we're adding 2/2. So we're getting 7/2. When you divide by 7/2, you get 2/7. Okay, plus 2 for that constant. I have my u. Adding 2/2, I get 5/2 times the 2/5, squeezing that in. Here I have my u. I get 3/2, which gets me a 2/3 there, and a plus c at the end. Finally, 2/7. U is really x minus 1. So I have to sub that out. 2 times 2 is 4/5. X minus 1 to the 5/2. Plus 2/3. X minus 1 to the 3/2 plus c. Okay, and I can see my board is running out over there. You're just not seeing the plus c at the end. Okay, so again, 2/7 times the quantity of x minus 1 to the 7/2 plus 4/5 times the quantity of x minus 1 to the 5/2 plus 2/3 times the quantity of x minus 1 to the 3/2 plus c. Okay? And that's probably our most challenging one so far. So maybe star that and maybe have yourself look back at this whole process again over here, because that is test level difficulty. Definitely one of the harder ones on a test, but definitely test level difficulty. Okay? All right, moving right along, we have our last page of examples at this point, just more of the same. If I were in class right now, I would ask you to recite the steps. Who would answer me? Allison would probably answer me, or Kayla. Who would not answer me? Jordan, you better be paying attention still. So what are our steps? Let's go over it. Our steps are, first, pick your U. And when you pick your U, you want to make sure, honestly, just start somewhere. Angela, you're going to be like, I don't know what U to pick. You're going to start to sweat. And I'm going to say, just pick something. Because if you pick something, you can start it. Okay, and then if you have to throw it out, Kaylee, you might need 12 pieces of paper on these things. But, you know, what happens, it happens. But pick your U. After you pick your U, take the derivative. After you take the derivative, solve for your dx. Once you get your dx, sub it back into the integration part of the problem. Check your letters, make sure everything jives, then integrate. Final step, sub it back out. Okay, so it's just very repetitive. You guys can do it. You can handle it. Okay. Last page. What do we have? 6 left. Okay. Starting to get a little bit more challenging at this point. Looking at this example, what should we make our U? So, choices again, you know, you could pick the 1 over x, you could pick the argument, you could pick the trig function. I always try to pick the argument when I have a chance to do that. So I'm going to pick pi x. Du dx would just be pi, and therefore du equals pi dx, and then du over pi is equal to dx. Okay, there's my math. Now I go through and I decide if it worked or not. So I'm going to write 1 over x plus the secant squared of u, and then my dx is du over pi. Okay, so far I would say no good. Why would I say no good? Because I have a u, I have an x, and I have a du. This pi, don't forget, that's not a variable, that's a constant. So that's not my concern because I'm going to pull 1 over pi right through that symbol. Okay? It's this guy that's bugging me. So think to our last example. Either I have to throw this all out and try a new u sub, or I have to come up with a creative way in this work to make this 1 over x turn to a u. So, if u equals pi x, is there any way to make that happen? Think. Okay, let's see. How about I divide by x? So u over x is equal to pi. Okay, that does get the x in the bottom, in the denominator. Well, how do I get the u out? Well, what if I divide both sides by u? That would cross the u out, and I would be left with 1 over x, and I would get pi over u. And by doing that, 1 over x can be replaced with a u. See that right here? So I'm going to do this to help this all stand out. So 1 over x, I'm going to write that as pi over u plus the secant squared of u. And then I'm going to write just a du here. Because remember, I took this pi and I pulled that through. Okay, so at this point, what could I do next? U, that's all nice and sub. Okay, so be careful. When I go through to do this, I can't just reduce those pi's because this 1 over pi is actually going to everything. So it would actually have a 1 over pi here as well. So let's do this. Let's do 1 over pi. We're going to integrate pi over u du plus 1 over pi integrate secant squared u du. This is a trick that we learned last section where this integration symbol can be broken up, right? We can take this integral and we can take this integral separately. Everyone sees that 1 over pi goes to both of them, right? Okay, so that's what I did. I rewrote them and I said, let me focus on this and let me focus on this separately. So this is just my choice in how I wanted to solve this. Now in this case, the pi's will be able to reduce, so I'll just be left with the integral of 1 over u du. Over here, I'm just going to recopy this. There was no issue in the first place. Okay, so here we go. What's the integral of 1 over u? The integral of 1 over u is going to be the natural log of the absolute value of u, which the absolute value of u was pi x, right? Okay, and I'll do a plus c, I guess, here. And then over here we have our 1 over pi. And then we have to take the integral of secant squared. Now what derivative has the answer of secant squared? That's tangent, right? So that means this comes off of our trig in our neon sheet. The tangent of u, and u again is pi x. And then plus c. Okay? In the end, you see how you have 2 plus c's. So in the end, you just need to write it once. And that's my final answer. Tricky.